Hi, in this lesson we're going to learn how to interpret and analyse the distance time graph. And one of the first things that you might like to do with the distance time graph is to take advantage of one of the key formula triangles that we learn in maths, which is that speed is distance divided by time. Now this is a distance time graph that also tells us the overall distance divided by the time. In this case, the overall distance covered was 50 meters and the time taken was 11 seconds. So that means that the average speed for this particular journey was 4.55 meters per second. Okay, so we can actually look at the entire thing. I know that we've got quite a varied journey, and we're going to discuss that in a bit more detail coming up, but that is the average speed for the whole journey. Okay, so that's one of the nice things that we can work out when it comes to this type of graph. Okay, let's look at it in a bit more detail now. We've got three distinct sections of this distance time graph. The first of which is this straight line here that goes between 0 and 2 seconds. Now the fact it's a straight line tells us that we are dealing here with a constant speed. And let's look at what I mean by that in a bit more detail now. The speed is distance divided by time. Now here, the distance covered is, I'm going to make that a bit straighter and nicer. The distance covered is 20 meters and the time taken is 2 seconds. Now hopefully that's quite reminiscent of something that we have done in the past. I'm not quite sure what's happened up here. Just a second. Oh no. Okay, I can deal with that, it's okay. Which is that rise over run. This is my rise, which is my distance, and this is my run, which is my time. Okay, and speed is distance over time. Well, that's the same as it being rise over run, isn't it? Okay, so in this case, it's 20 meters divided by 2 seconds. Now, 20 divided by 2 is 10, so it's 10 meters per second. All right, but what I'm getting at here is that the speed is the same as the rise over the run. So actually the speed is the gradient of the distance time graph. That is really, really important. Okay, that needs to be put in a cloud because it's so important. Okay, so the speed is the gradient of the distance time graph. All right, so in this case, my speed at this point is 10 meters per second. That's significantly faster than the average speed of the whole journey. All right, and probably the reason for that is coming up in the next section of the distance time graph that runs from 2 seconds to approximately 7.5 seconds. Okay, because what's important that's happening here is that no distance is being covered at all. And as soon as the distance time graph goes horizontal like this, where the gradient is 0, okay, let's go back to this. The gradient is 0, it's flat. That means the speed is 0. Okay, if the speed is 0, then we are now stationary. Okay, we are stationary, we are not moving. The speed is 0. All right, so that probably contributes to the fact that my average is much, much lower than this initial 2 seconds. Now, the final part of this distance time graph is this curvy bit. Now, we're not able to find really very easily a rise over run for this. We can see here that the gradient is quite shallow here, gets steeper, and then gets more shallow again, which leads us to think that, yeah, okay, we're probably going fastest here because the gradient is going to be the steepest. And the way that we would actually work out the gradient at, say, this point here, is that we would have to draw for ourselves a tangent, okay, to the curve. And that means that we're going to, take perhaps where, we want to find the speed where we're looking at 9 seconds into the journey. We would have to then draw for ourselves a tangent. Now, that's not a great tangent. I'm just going to adjust that slightly, if I can. Yeah, okay, maybe not. Let's try it again. Sorry about that. Let's try it again. So, yeah. Let's draw a tangent as best I can, like so, perhaps. Yeah, okay. And then from that tangent line, then we would do a rise over run. We'd measure between 2 points, a rise and a run, and we find a difference in the distance, divide it by the corresponding difference in the time taken, and that would give us the gradient, i.e. the speed of the person or the object at that particular point in time. Okay. All right, so when it comes to that, and we would have to draw a tangent to the curve, what we've got here is a curvy line tells us that we've actually got changing speed, okay? And we need to draw a tangent. We need to draw a tangent to find the gradient. That is the speed, okay? All right, so I hope that's nice and clear. They're the key features. That's how we would analyse a distance time graph. Okay, please give us a like and a subscribe, and see you next time.